In this lecture, we're going to discuss the quantum numbers. By the end of this lecture, you should be able to name the four quantum numbers, know what their symbols are, be able to give their values, and know what each one represents. So, what are quantum numbers? Well, quantum numbers are used to identify where an electron is within an atom. So each electron can be uniquely identified by its four quantum numbers. So I now want to tell you what the four quantum numbers are. The first quantum number, known as the principal quantum number, is given the symbol N, and it tells you the energy level. So is it in the first energy level, the second, third or fourth, etc. The second quantum number has got the rather unhelpful name of the angular momentum quantum number. It's given the symbol L, and it tells you the orbital shape. Is it an S orbital, a P, a D or an F orbital? The third quantum number, known as the magnetic quantum number, given the symbol M, tells you the orientation of the electron orbital. Now, S orbitals only have one orientation, but P orbital could be Px, Py or Pz. And a D orbital, there's 5 different orientations, and an F orbital, 7 different orientations. And the final quantum number, the spin magnetic quantum number, given the symbol S, tells you the electron spin, tells you if this electron is spinning in a clockwise or an anti-clockwise direction. So, if the principal quantum number has the value 1, then the value of L can vary between 0 up to a value of n minus 1. So, if n equals 1, the value of L has got to be 0. And remember, that's telling you the shape of the orbital. So, if the L value is 0, that's telling you it's an S orbital. The value of M, the orientation, varies from minus L all the way up to positive L. So in this case, L is 0, so the orientation can only have the value 0 because an S orbital only has one possible orientation. So if its first 3 quantum numbers are 1, 0 and 0, then it's a 1s. The electron is in a 1s orbital. If the principal quantum number is 2, then L can go from 0 to 1. So 0 if it's an s orbital, 1 if it's a p orbital. For the s orbital, the value of m is always 0. For the p orbital, m can be minus 1, 0 or plus 1, which corresponds to a px, py and pz orbital, although not necessarily in that order. So if it's 2, 0, 0, it's a 2s orbital. If it's 2, 1 and any of these numbers, then it's a 2p orbital. The electron's in a 2p orbital. So when the principal quantum number is 3, L can be 0, 1 or 2, corresponding to an s, p or d orbital. So the value of m can be 0 for the s, minus 1, 0, plus 1 for the p, and for the d orbital, and go from minus 2 to minus 1 to 0 to plus 1 to plus 2, representing the 5 different d orbitals. So 3, 0, 0 is a 3s orbital. 3, 1 and any of these numbers is a 3p orbital, and 3, 2 and any of these numbers is a 3d orbital. And finally, the principal quantum number is 4, so if we're in the 4th energy level, we could either be in an s orbital, a p orbital, a d orbital or an f orbital. So the values of m be 0, minus 1, 0, plus 1, minus 2, minus 1, 0, plus 1, plus 2, and for the f orbital, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, 7 different options. So 400 is a 4s orbital, 41 is a 4p, 42 is a 4d orbital, and 43 is a 4f orbital. The final quantum number, the spin quantum number, only has the values plus a half or minus a half, depending whether or not the electron is spinning in a clockwise or an anti-clockwise direction. So let's look at a couple of electrons and their quantum numbers. So if an electron has a principal quantum number n equal to 2, that means that electron is in the second energy level. If its angular momentum quantum number L is 0, that means that it's in an s orbital in the second energy level. Its magnetic quantum number m will be 0 because for an s orbital there only is one orientation. So this tells us that we have an electron in a 2s orbital. The final quantum number gives us its spin. So if a spin magnetic quantum number is plus a half, that means it's spinning in the clockwise direction. If we look at another electron and it has the quantum numbers 200 minus a half, that means that this electron is also in the 2s orbital, but it's spinning in the opposite direction from the other one. So to recap, by now you should be able to name the 4 quantum numbers, know their symbols, be able to give the values for each one, and you should know what each quantum number represents.